This is Algebra 2, Unit 5, Lesson 5 on geometric series. Now, just as we can sum the terms of an arithmetic sequence to generate an arithmetic series, we can also sum the terms of a geometric sequence to generate a geometric series. All right, now given a geometric series defined by the recursive formula, a of 1 equals 3 and a of n equals a of n minus 1 times 2, which of the following is the value of s of 5, or the sum of the first 5 terms of this sequence? Okay, now remember, a geometric sequence is increasing by multiplying. So this says to sum the first 5 terms of the sequence. So whatever the terms of the sequence is, 1 through 5, we're going to add together. That's what the S means. Okay, so we need to know the first 5 terms of the sequence. All right, so we know A1 is equal to 3. There's my first term right there. Now A2, I need to use this formula, the recursive formula. Whatever term I'm on, a of n, what term would this be compared to this term? Well, if this is n minus 1, this would be the previous term. And what do we do with the previous term? We multiply it by 2. So this is a geometric series because we're multiplying. So this says for A2, I need the first term, which would be 3, times 2 is 6. The third term would be the previous term, which would be 6, times 2 is 12. And then a of 4 would be the previous term, 12, times 2 is 24. And a of 5 would be 24 times 2, which is 48. So if I want to add these together, 3 plus 6 plus 12 plus 24 plus 48, 1, 2, 3, 4, 5 terms of the sequence. If I add them together, 3 plus 6 plus 12 plus 24 plus 48, there's my first 5 terms, I end up with 93. So the sum is going to be 93. So that's number 3. Okay, so the sum of a finite number of geometric sequence terms is less obvious than that for an arithmetic series, but can be found nonetheless. The next exercise derives the formula for finding this sum. Okay, now recall that for a geometric sequence, the nth term is given by a of n equals a of 1 times r times n minus 1. Now remember, the r is the common ratio, which means what you multiplied by. It is the multiplier. Okay, and when you multiply the first term times the common ratio, you multiply it, whatever number of term you're on, 1 less than that, because you're starting at the first term, not the 0 term. So if I'm going, for example, to the 10th term, I would multiply r 9 times. If I'm going to the 15th term, I would multiply r 14 times. So just to remind us what the geometric sequence means. Okay, so S of n for a geometric series, all right, and this means the sum of n terms. And you can see first term times the common ratio, first term times the common ratio twice, and dot, 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 and then first term times common ratio 2 less times than the term you're on, and this would be 1 less time than the term you're on. Okay, so this would be the sum of the series. So this makes up all the terms of the sequence. Okay, so write an expression below for the product of r and Sn. All right, so if I take r and multiply it by Sn, so this is going to be r times a1 plus a1r plus a1r squared plus dot, dot, dot plus a1r to the n minus 2 and plus a1 r to the n minus 1, and that would be the final term of my sequence. Okay, now if I multiply these together, I end up with a1r, I'm distributing, plus a1r squared plus a1r cubed plus dot, dot, dot a1 to the r to the n minus 1 plus a1 to the r, to the r n. Okay, so if I'm taking the value here, find in simplest form the value of s of n minus r s of n in terms of a1, r, s, and n. All right, so if I take this and I subtract this one from it. All right, so if I take this I end up with, well, A1R, A1R, A1R squared, A1R squared. A1R cubed would be the next term, dot, dot, dot. And I would keep going, and I would end up with A1 minus A1R to the n. Okay, so this would be the formula. Write both sides of the equation and b in their factored form. Okay, so if I took s of n minus r s of n, r times s of n, is equal to a1 minus a1r to the n, and I factor both sides. Well, this side will GCF out the s of n, which is going to be 1 minus r, and this one is going to factor out a1 times 1 minus r to the n, and then I want to solve this equation for Sn. Okay, so if I solve this for Sn, I just have to divide by 1 minus r. So S of n is going to equal a1 times 1 minus r to the n over 1 minus r. So what we have just come up with is a formula for the sum of a geometric series. Now you can see it like this, or you may see it on the Regents reference sheet with the a1 multiplied through. So on the Regents reference sheet, you would see S of n equals a1 minus a1r to the n over 1 minus r. So if I put up the Regents reference sheet here, here's the Regents reference sheet, and we go down to the geometric series, you can see this is the same formula. They just distribute the a1 through the equation. So it doesn't matter which one you want to use, it's up to you. You can use either formula because they mean the same thing. Okay, so let's apply the formula. Remember, the formula is S of n equals a1 times 1 minus r to the n over 1 minus r. So if I apply the formula, I'm going to write it down here. S of n equals a1 times 1 minus r to the n over 1 minus r. Or you can distribute it through what's on the reference sheet, a1 minus a1r to the n over 1 minus r. Either one of those would work. Okay, so let's fill in our values. Which of the following represents the sum of a geometric series with 8 terms, whose first term is 3 and whose common ratio is 4? Okay, so I'm having how many terms? N is going to be 8. So S of 8. The first term is 3. So A1 is going to equal 3. So that's going to be 3. 1 minus the common ratio, which would be R, is 4. And then that's going to be raised to the 8th power over 1 minus 4. Okay, so all I have to do is put this in my calculator. All right, I can even use the alpha key so I can do it all at once. Whoops, I hit the wrong button. Alpha, y equals, sorry. Number 1. All right, so I have A1, which we said was 3, times 1 minus 4 raised to the 8th, close your parentheses, and then divided by 1 minus r, which was 4. Okay, and we press enter, and we get 65,535. All right, so this works out to be 65,535. All right, if you could put it in as this as well, it will get the same answer because this is just the factored form of this. So it's going to be number 4. All right, so here is our formulas for the sum of finite geometric series. Okay, so for a geometric series defined by its first term A1, its common ratio R, and the sum of n terms. Here is the factored form. Here is the form that is on the Regents reference sheet. Either one will work. Okay, so let's try this next one. Find the value of the geometric series shown below. Show the calculations lead to your final answer. Okay, so the first thing we need to know is the value of the geometric series. How many terms are in the sequence? Do we know? No, we don't know n yet. So n, we've got to figure out. All right, do we know a1? Yep, a1 is 6. What is r? Well, if we look at our terms here, the first term is 6. the second term is 12, the third term is 24. What are we multiplying by to go from term to term? It would be 2. So r is going to be 2. So we know our common ratio is going to be 2. Okay, so in order to do this, we need to know what n is going to be. All right, now, to figure out n, we need to know what the number term sequence is. So we're looking for a of n. Now remember, the formula for a geometric sequence is the first term, a of 1, times r to the n minus 1. Okay, so we need to know what n is. All right, so what we need to do is pick the terms of the sequence. All right, well, we know that the last term of the sequence is 768. So to figure out what the n is going to be, I'm going to plug in 768 because that's the last term of my sequence. So this is going to be, a1, we said was 6, times 2 raised to the n minus 1 will equal 768 because that'll be the last term of the sequence. Okay, so let's solve this. All right, so we have to get the 2 to the n minus 1 by itself, so we have to divide by 6. Grab my calculator. 768 divided by 6 is 128. All right, so this is going to be 128 is equal to 2 to the n minus 1. Okay, now 2 to the n minus 1, isn't 128 have a base of 2? Yeah, 2 to the 7th is 128. So if I have the same base, what do I do with the exponents? Well, n minus 1 will equal 7, so that means that n is equal to 8. So I'm actually going to be 8 terms of the sequence. So this is the first term, second term, third term. This is going to be the 8th term of the sequence. Okay, so now we have all the pieces we need to use this formula. You can use either one, it doesn't matter. All right, so S of 8, because we're looking for 8 terms of the sequence, is equal to A1, which is 6, times 1 minus 2 to the n, which was 8, over 1 minus 2. All right, so S of 8 equals, I go to my calculator. I'm going to use my alpha key so I can put it all in at once. All right, so on that, it's going to be 6 times 1 minus 2 raised to the 8th, close your parentheses, divided by 1 minus 2. And it's equals 1530. So if I added the first 8 terms of this sequence, it comes out to be 1530. So there we go. All right, so the geometric series works either way, so however you want to do it. If you are more comfortable using the other form, that's fine. This would be S of 8 is equal to 6 minus 6 times 2 to the 8th over 1 minus 2. You will get the same answer. It doesn't matter. Okay, so let's save number 5 and number 6 for the next class, and we'll be working on those in a few minutes.